I'm Sarah Schmidt, and in this video I'll describe my paper, BOSS Ultracool Dwarfs 1, the colors and magnetic activity of M and L dwarfs. This paper centers on the BOSS Ultracool Dwarfs sample, which includes nearly 12,000 objects with spectroscopy from the Sloan Digital Sky Survey. In addition to optical spectra, we also examined the SDSS, 2MATS, and WISE photometry. These two histograms show the spectral type distribution of our sample, in addition to the number of objects in each spectral type bin with IZ, JHK, and WISE photometry. Using this photometry, we examined the ultracool dwarf color locus, or the position of ultracool dwarfs in color space. These two plots show the Z-J and W1-W2 colors as a function of I-J color. The BOSS Ultracool Dwarfs are shown in grayscale pixels, and their median and standard deviation in each color bin is shown in red. The blue points show the stellar color locus, work by Jim Davenport. Each panel shows the evolution of color from F stars to early L dwarfs, and our paper includes the BOSS Ultracool Dwarf color locus in 7 different colors, and examines these colors as a function of spectral type. In addition to looking at colors, we also examined magnetic activity characterized by the presence and strength of H-alpha emission. Here, we examined the fraction of dwarfs with H-alpha emission as a function of spectral type. The data release 7M dwarf sample is shown here in red, with a number of objects used to calculate the fraction shown above or below each point. We can see the increase in active fraction from M0 to M9. When we include the BOSS Ultracool Dwarf sample, we see the fraction continues to increase to L0. When we combine the BOSS Ultracool Dwarf sample with L dwarf data from literature, we find that the active fraction peaks at L0, then decreases towards late L dwarfs. The increase in fraction from M0 to M9 is primarily an age effect. Late M dwarfs stay active longer than early M dwarfs, so we are more likely to see an active late M dwarf. The decreasing activity fraction from L0 to late L dwarfs isn't an age effect. It's better thought of as an effect of activity strength. Here we see activity strength, or the ratio of the H-alpha line luminosity to bolometric luminosity as a function of spectral type for the entire SDSS sample. The red dashed line shows a rough detection limit. The light gray boxes show the full range of activity strength in each spectral type bin. The dark gray boxes show an interquartile range, and the points show median. The median activity strength is constant from M0 to M4, but then declines from M4 through mid-L spectral types. As part of my paper, I ran a series of toy models trying to understand and reproduce these observed activity trends. The chromospheres of M dwarfs are all similar. That is, from M0 to M8 spectral types, they have a similar chromosphere temperature structure and similar surface area coverage. The chromospheres of L dwarfs, however, are much weaker. They are either much cooler or cover a much smaller fraction of the surface. This is consistent with other work saying that it's difficult to heat chromospheres on the cool atmospheres of L dwarfs, and that the mechanism for magnetic heating may change entirely between mid-M and L spectral types. For more information, please see my paper, available on the archive. Thanks for listening.